Greetings and welcome to another video by Mr. Nagengast. Today we are going to look at more applications for chapter 14. In other words, we're going to look at a right triangle trig problem. We'll look at a law of sine and hopefully a law of cosine. And then give you a couple problems in which you can work on by either pausing the video or just writing it down and doing your best. And then come with questions in the morning if you have some. A rescue helicopter, if we begin on number 1, a rescue helicopter flying at a height of 2,000 feet, so I'm going to underline the important information that grabs me, in the air locates a fire by an angle of depression of 72 degrees. At the same time, his co-pilot, looking in the same direction, spots a group of hikers at a 45-degree angle of depression. Now it says draw a sketch for this situation. So I'm going to make my quick little helicopter sketch here. I sure hope you enjoy it because I sure do. There's my helicopter. He's flying around and he notices what's going on. So his angle of elevation starts with a line of vision straight out, parallel to the ground. And he notices as he looks down, his angle of depression is 72 degrees. So fairly sharp angle down. He spots the fire in which they were looking for. I'll designate that with F. See, isn't that a cool fire? Okay, so he spots this fire. His co-pilot at the same time, looking at an angle of 45 degrees, spots a group of hikers. Now, we'll remember that at this point, they gave us the information that this helicopter is 2,000 feet above the ground. Now, we don't know exactly how far apart the fire is from the hikers or how far the helicopter is from the hikers or the fire. But we can make two triangles with these angles of depression. The first one, if you remember, I'll mark it in blue, said that it was going to be 72 degrees. Now, the second angle was at 45 degrees. So 45 degree angle and a 72 degree angle. And so now what we're going to do is we're going to use our right triangle trig, and how we're going to do that is I'm going to make a triangle up to the line of sight if they're looking straight ahead for the first one. And I'm going to do that for the second one. And you'll notice I have two triangles. A small triangle in blue here and a large triangle, and I'm going to cover this up now, in green going across. So you see that they kind of overlap. Now I can get these two distances. I can get this full distance here, and I can get a small distance here. What that enables me to do is find this distance. So that's going to be a question mark that we're going to solve because eventually it's going to ask us some questions. And here's the question. How far away from the blaze are the hikers? So they really want to know right here. How far away are these people? Well, that's this portion of the triangle on top right here. Okay, so let's get the full distance. We're going to use right triangle trig. So I know that my angle is 45 degrees. And I know that this height over here is also 2,000 feet because that's the height of the helicopter. So what can I use to find this total distance going straight across here on top? Well, that's the adjacent side, and I have a value of the opposite side. So I'm going to use the tangent of 45 degrees will equal the opposite over the adjacent side, which is what I don't know. So with this setup, we're going to see we want to solve for a, so I'm going to do what I like to call the old switcheroo. I'm going to multiply each side by a, so I have an a on this side, and I'm going to divide each side by tangent of 45 degrees. And so now what I need to do is work this problem by typing in 2,000 and dividing it by tangent of 45 degrees. So please make sure your calculator's mode is set for degrees. And when I do that, oddly enough, I find out that I end up with exactly 2,000 feet. Okay, so I know that the long distance here is 2,000. Now I need to find this shorter distance. I need to find the distance for this blue triangle right here. Again, I'm going to set up my right triangle trig, which will tell me that the tangent this time is of 72 degrees. And I'm going to set that equal to the opposite over adjacent, which again, the adjacent, I don't know on this one. Maybe we should call it a different letter. Let's call it x. And I'm going to again switch the two positions. So I'm going to get x equals 2,000 over tangent of 72 degrees. And this time when I work that out, I end up with a value of 649.84 feet. And that's what my x equals. Now, do we have enough to answer the question at hand, which was how far away? So B, the question was how far away are the blaze and the hikers? Well, the blaze's total distance is 2,000 feet. So we're going to take 2,000 feet and we're going to subtract from it the distance that the hikers are, which is 649.84 feet. So I'm going to put that into my calculator and find a value of 1,350.16 feet separate the hikers from the fire. So that's how I did B. Now let's look at C. C is asking me simply, what is the diagonal distance between the hikers and the helicopter? So where is that diagonal distance? Well, that diagonal distance, as I'll use black, is right here. This is where our diagonal distance is, as they look down at the fire. So let's find out what that diagonal distance is. We're going to use the smaller of the two triangles. Now I have a distance of 72, not a distance of 72, but a degree of 72. So how can we set up this triangle for part C? Is to look at what we want, which is the hypotenuse, and know that we already found that length, which is the adjacent. So what deals with adjacent and hypotenuse is the cosine. So the cosine of 72 degrees equals the adjacent, which we found as 649.84, which maybe it might have been best for me to just round to 650, but I'm going to go for a little more exactness, and that is all over the hypotenuse. Now in this case, again, I am stuck with the old switcheroo and end up with h equaling 649.84 divided by cosine of 72 degrees. So let's go ahead and work that one out. And we should obtain 2,102.93 feet distance between the helicopter pilot and those hikers. Now I'd like you to try this one, so hit pause and then do your best on this, and then I will display the answers once you start again. Well, welcome back, and let's see how you did. You can, again, pause this. I just want to point out a couple things, and the one main thing I want to point out is that I had to multiply by the 35 so that I would get h by itself. The second thing I want to point out is that we added 6 feet for her height. So that is this height here that was not accounted for. Okay? And then the last thing is for part B, If she is looking up at an angle of 27 degrees, a person looking down, going across in this blue, has an angle of depression that equals that 27 degrees. Here's another problem in which I'd like you to try. I will leave that solution for tomorrow to discuss in class, but I would like you to give it your best attempt. And I'm going to move on to another problem. And the problem I would like to look at is this one. And it gives us a picture. And you'll notice we have a degree of 25 here, a side, and then a side opposite. Once I have that angle and the side opposite, I should be thinking of law of sines for this one. Law of sines. Now, law of sines tells me that I'm going to try to figure out this value with the information I'm given. Let's see what it asks. It says that a reservoir supplies water through an aqueduct to Springfield, which is 15 miles in length. So there's our length there. And then it says from a reservoir at 25-degree angle southeast. And so we've got a reservoir, we've got our city, and then it says it will, the pumping station will be 7.5 miles to Centerfield, which is over here. So there's our 7.5. And plans have been made to build an aqueduct directly. So what they're really looking for is in red here. They're going to want this distance. Now, are we ready to find that distance with what we have? Probably not. But we will be able to get an angle here, and then that will tell us what this angle is, which will allow us to get this distance. So I'm going to do probably the law of sines twice. Now the first thing I notice is I'm going to take, I want an angle, so I'm going to try to find the sine of, well, let's call this B, and so this is little b, so the sine B over 15 will equal my sine of 25 degrees all over 7.5. Now I'm going to go ahead and cross multiply by 15, leaving me with sine of B equals the following. So you can see I need to put this into my calculator as an inverse. So I came up with a decimal. Now I'm going to do second sine and type in the point 84523 into my calculator, giving me an estimate, and my degree then is 57.7 degrees. That's what I have. Now I can take this angle degree measure and realize that I have this B here, and I can come up with the measure of angle C. So the measure of angle C then will be, in fact, 180 degrees minus that 57.7 and subtract the 25 degrees. So that gave me a 97.3 degrees, which I then set up in law of sine. Notice my unknown goes in the top left, and then I can cross multiply. When I cross multiply, I end up with C equals 17.6, and in this case, it will be miles. This final example has an observer here on Earth looking at two stars, one that is 9.5 light years away from the Earth, and the other in green that is 4.6 away. So I'll call this star 2 and the other one star 1. Now the question is, how far apart are the stars? And we were given this 43 degree angle. So what that tells me is I'm going to find this question mark, which I'll square it. So I'll just call this question mark A. So I've got A squared equals what pattern? So poof, there is our solution that we're going to use. I'll call my B my 9.5 and my C my 4.6. So now I'll fill it in. And the substitution gives you this line here. Now you can put that directly into your calculator and get something like 47.44, or maybe it's 47.48 when I didn't do this rounding step. That will give us cause to square root each side, giving us 6.89 light years away, which tells us we had a side angle